first of all, welcome. Thank you for coming to the second of our three-part stormwater series. Our first event was Stormwater 101. That is recorded online already. So if you're interested in watching, it is available. Today is Turfgrass nutrient management updates with John Emerson. And then our last workshop is going to be community enhancement and funding opportunities. So we're going to have Blake in the back there talk that day. And then we have two other folks with DENREC coming in to talk about funding opportunities. I will talk at the end real quick about some things that the district has going on coming up. But I think we're just going to run into it and get started with John, if that's okay.
Thanks, Mom. Two questions. Where do we find the recording?
So I can go over and show you on our website at the end.
Okay, and then the charts from today, are they going to be available as well?
So it is being recorded, and as soon as I get it back from UD, I'll get it online.
So just the recording, not the charts themselves.
Well, the
If
presentation.
you need them, I can give them to you.
Well, I'll
So
talk to you.
usually what I'll do is I'll have the recording and then also a link for the presentation.
Thank you.
You're welcome. So,
You good?
John's up.
All right, thank you, Sean. I appreciate it. Okay, welcome. My name is John Emerson. I'm Turfgrass Extension Agent at the University of Delaware. 60% of my time is spent with the nutrient management program, and the other 40% of my time is with the pesticide safety and education program. But I primarily work with the turfgrass and ornamental industry. So today, I'm going to talk about the Delaware Livable Launch Program. Just a quick show of hands, who's heard about the Delaware Livable Launch Program? Okay, most of you. Okay, that's good. So this is Delaware Livable Launch 2.0. And I'll talk about why I wanted to kind of change a little bit, not necessarily the complete direction of the program, but to tweak it a little bit to kind of move along with what the science is telling us with nutrient management. And then also talk about fertilizer BMPs, nutrient management BMPs, and then at the end, I've got a few slides to debunk some common myths that are strongly held in the industry.
Real quick, do you want to ask questions during or do you want to wait till the end?
If you have a question in the middle and something isn't clear, because there's a couple topics that are pretty dense in here that I'm going to talk about. So if you do have a question, just raise your hand. If I can't answer it fully, or if it's going to take more time than I need, or kind of throw me off my game a little bit, we'll save that to the end. So if it's pressing, raise your hand and we'll take care of it. So there's my information. If you ever need to get in contact with me, it's my cell phone. I don't put my office phone up there just because I'd rather you call me directly anyways. Okay. Couple housekeeping items. So just an FYI, and back in the spring, the Delaware Senate passed a new nutrient management law specifically for the turfgrass industry. Okay, so in the past, it was 10 acres or more, and you needed, which would trigger the requirement to get a nutrient management fund or get certified by the nutrient management program. That number, 10 acres, has been now decreased to a quarter acre. So if you have a landscaping or a lawn care operation business, and you are managing or applying fertilizer to more than a quarter acre, guess what? You're in now. So pretty much if you're applying fertilizer in the state of Delaware to turfgrass and ornamental systems, you're getting paid to do it. You need to get certified. This law, I believe it's SB 318 is the name of, don't hold me to that, but the governor just signed it back on the 24th of September. So it is in effect. Whenever, at some point, the Department of Ag and those folks, they're going to release some kind of press release or some kind of statewide statement or what have you. But anyways, so enough about that.
John, I have a question.
Go ahead.
So that quarter acre, that's only for the turf industry, right? That's not ag.
For professional applicators, not homeowners?
No, so if you're getting paid to do this, it's part of a business.
But is it just
For turf.
yeah,
turf.
So the ag didn't change.
No, ag is still the same. So if you have an agricultural operation, you're still with the old 10 acre rule.
So if we're from an HOA and we have common areas, so should we make sure that our landscaping company has the certification? We have the right to ask them
You absolutely have the right to ask them, whether you employ them or not, that's up to you.
Okay,
But theoretically,
they should be.
they should be, yes.
Okay. And is there like, what is the time that they have to have it by?
I believe they're going, being that this is a pretty severe change from 10 acres to a quarter acre. I don't know what the Department of Ag what their leeway is gonna be for the folks to get certified, but I believe it's gonna be sometime, maybe 26, don't hold me to that number, but maybe they're gonna give you at least a year. And within that year, we hold 3 certification sessions. So there's plenty of opportunities for those folks to get certified within a 12-month period. So with that said, we have certification sessions coming up in December. So if you or someone you know that falls under this new umbrella, needs to get certified, reach out to us. Gioella Del Vecchio is our program coordinator. That's her phone number, and that nutrient-management@udel.edu is a general mailbox for everybody in the program. We will all see that. So if you want to get registered, reach out to us and we'll put you on the list. I have an event coming up. This is kind of late notice, but in October 18th, I'm going to have a turfgrass plot walk and a field day style event. It'll be about an hour and a half that's a Friday. And that'll last from 4 to 5:30 up in Newark. You can scan this QR code, or you can go to this tiny link here. We're going to cover a bunch of things. I built a turfgrass research and demonstration area up on the Newark Agricultural Research Station, right out back of Townsend Hall, and I use that for things like this: field days and plot walks. There's just some of the things we're going to cover. But you're going to get both pesticide and nutrient management. I'm going to jump into Delaware Livable Lawns first, and I'll explain what it is, what the program entails, and then why and how I went about changing the fertilizer recommendations. But Delaware Livable Lawns is a partnership between Department of Ag, DNLA, DelDOT, DNREC, and University of Delaware. And this is a program to promote improving our water qualities, which we're all interested in, following fertilizer best management practices, and of course, environmental stewardship. And the way I kind of thought about this, I was like, the way that these current nutrient recommendations for the program are structured, it just didn't jive with what the science of nutrient management for turfgrass systems is saying. And it also kind of restricted some of the applicators as well. And we'll talk about that a little bit more in detail. But the Delaware Livable Lawns program is not only for commercial applicators with a business, it is also for homeowners can follow this program as well. So for the commercial arm of this, this basically is telling individuals who may employ a particular business, if they are Delaware Livable Lawn certified or commercial certification, it's saying that these companies, this certification tells the public that these companies follow environmentally friendly best management practices, and they're also going to assist and help educating their clientele as well. This is a voluntary program. It's not regulated by any agency, so this is something you're doing at your own free will. The same thing goes for the residential arm. This is for the DIYers and the particular homeowners. The fertilizer guidelines are going to be the same for both the homeowners and the commercial certified commercial applicators. There's more emphasis on creating a diverse landscape for the DIYers because you have a little more leeway and a little more access to being that it's your own property. But you want to try and create buffers around waterways where possible, and just follow general best management guidelines, best management practice guidelines. Okay, so what is required for certification and or participation in the Delaware Livable Lawns program? Some of these things are no-brainers, right? We should already be doing this. For example, keeping fertilizer and grass clippings off the sidewalks, concrete, and other impervious surfaces. If you mow your grass and you blow clippings out into the street or into the sidewalk, blow them off. Same thing with fertilizer. But being a commercial or certified commercial applicator with the program, you're going to be giving out, or you're going to be given various educational materials to hand out to your clientele. And for the commercial arm, for all your new accounts, you're going to test the soil prior to making any phosphorus application. Okay, so you can't just take on a new set of customers and go out and start applying phosphorus because you don't know exactly what the nutrient concentrations are at that time. And the idea here is that we only want to apply phosphorus when it's absolutely necessary. Okay. And then for established accounts, soil test goes every 3 years. Okay. And of course, you're going to follow the Livable Lawns guidelines. And then you're expected to calibrate your spreaders. And as a commercial venture, you are expected to have a certified commercial nutrient handler and certified through the state nutrient management program. You're expected to have one working for the company, either as the company owner or one of your applicator technicians. A couple of additional guidelines. So I talked about providing residents with educational material, but you're also going to provide them with copies of their soil test and then walk them through that, and or at least have the ability to make it not a jumbled mess in your head. And then you're expected to seed with recommended varieties. And I just updated the all of the both warm season and cool season grass species. I just updated that list, and you can find that on the UD Extension website with all of the best performing cultivars for the state of Delaware. And then use slow release fertilizers whenever possible. Because the end goal here is we're trying to reduce the amount of nitrogen and phosphorus that we're putting into our water, right? And cleaning up our waterways is priority number one. I would like to see more industry participation. And when I say industry participation, I mean the folks that are getting paid to do it. So I would like to see more folks get involved with that. And then, of course, going forward to the future, as the science changes, we're going to adapt the fertilizer guidelines to be reflective of that.
John, is there a list somewhere of the people who are certified for this? And if so, where is it?
If you wait one more slide,
Okay,
I'll
great.
get you there.
Okay.
So in addition to some of that educational material as a commercial applicator that you would get, you're also going to get thousands of dollars of free marketing materials. So you're going to have flags and things like that you can put in people's lawns. You're going to get magnets and stickers that you can decorate your trucks or vehicles with. There's a whole laundry list of marketing and promotional materials that will be free to you as a Delaware Livable Lawns commercial applicator. Business cards, you name it. And it ends up being thousands of dollars of materials. Okay, so here's who's currently certified. Actually, we just certified another business, and you'll have to forgive me. If you're really interested, you can reach out to me and I'll tell you their name, but I can't remember their name off the top of my head. But they are located in Wilmington. What's that? Go ahead. Oh, did we? Okay, good. Okay, so there we go. We have two more. All of these businesses that participate in this program are all well run. They're well respected within the industry. And as someone who may be actively seeking out someone to manage their property, this is the list that I would go to first. This is the list that I recommend that you go to first, right? So if you're an HOA, boom, this is where you go first. This is who I'm looking to manage my property. These people have happy customer bases, right? And mistakes and callbacks and errors and application, they are inevitable. But it is much less common with this group of applicators than it is with the standard lawn care operator landscape group. And so with that said, if you're looking for someone, please refer to this list. You can find this list on the Delaware Livable Lawns website. Reporting requirements, this is not for the DIYers or the homeowners. This is only for the commercial applicators. As a commercial applicator, you already have to send this information into the DDA every year, right? If you're certified by the nutrient management program, you have to send in how much nitrogen and phosphorus you applied as part of your business through that year. All you're going to do is copy and paste that onto a similar form and send that to us at the Delaware Livable Lawns. And then occasionally we pull one out to audit to make sure that they're following along with the guidelines. So a couple of management challenges from the old guidelines. Not to mention the science kind of disagreeing with it, but just some general management challenges that the commercial industry was dealing with was that aesthetics drives the bus, right? That's what everybody's worried about. Do I have a green, healthy lawn? And sometimes, especially in the South, down here in the South, where sand content gets increasingly higher as you move south in Delaware, nitrogen doesn't hang around as long, okay? And so having that summer blackout window, which was part of the old Livable Lawns guidelines, that just wasn't conducive. And that was one of the reasons why I decided to change. So another thing too is that lawn care operators, a lot of times, these landscape or lawn care operations, they manage athletic fields. And we needed a way to separate that from managing a typical lawn. And a challenge with this is if you won't do it, if a particular company won't apply a particular product that you want, and I'm typically speaking about nitrogen here, they're going to find someone else who will. And so that summer blackout window was really hamstringing a lot of people, and so that was one of the main drivers. So here are the old guidelines. We'll just kind of walk through this a little bit. We have turfgrass species all the way over here on the left. First row are cool season grasses, tall fescue, ryegrass, etc. And then that second row is our Bermuda grasses and our zoysia grasses. The max amount of nitrogen applied to be able to be applied per year is 3 pounds of nitrogen per 1,000 square feet. For both, that doesn't change from the old guidelines to the new guidelines. But this was a little confusing, and I thought having a blackout period in the summer just didn't make sense. But when you look at this, it's like, well, can you apply in May and June? We don't know, and sometimes that was a little overwhelming and confusing to the folks, and we tried to simplify it. The next slide that I show you looks busier, but is much easier to understand, okay? And then, of course, the blackout restriction of only being able to put down a 0.5 pound of nitrogen per 1,000 square feet from, what was it, June, July, August. I mean, a lot of times that's not going to cut it in a really sandy soil, right? That those sandy soils lose nitrogen at a very rapid rate compared to a heavy clay soil. Of course, the December 7th to February 15th blackout period, that is statewide. Nobody can apply anything but lime during that period. Okay, so we just saw the old guidelines, and here's another thing that I thought about. I'm going to introduce a topic to you, which also drove some of the reasoning behind making new guidelines. Everybody has seen a chart like this or something similar, right? At some point in your life, you've seen a chart similar to this. Well, I don't like this chart. I don't think this is very indicative of actually how turfgrass grows, how it does photosynthesis. I just don't agree with this, because here, if you look at the light green graph there, would you say in June, July, and August, or even into September a little bit, you would say that the grass is barely growing, right? Is that how you would interpret that? Is that how most people interpret that? Yeah, and that is just not correct. I mean, the grass is growing at a very rapid rate. It's producing sugars and carbohydrates at a very rapid rate, June, July, and August, okay? It's just very stressful and very difficult And photosynthesis is very inefficient during this time, but it's still growing very rapidly. And the same thing goes for the dark green hump there, right? You would think, looking at that warm season grasses in the summertime, they're growing at their maximum capacity. That's just not true. We're at a sliver of the maximum capacity due to how mild our shoulder seasons are, okay? So I want to introduce this idea of growth potential, okay? This looks a little busy, and don't worry about this, this equation here. You don't have to solve it. So this is the idea. This is strictly taking into account temperature, because with turfgrass systems, well, the only other limiting factors we can have will be nutrients, light, and water. We got all those covered. We apply nutrients, we apply fertilizer. Typically, we have irrigation covered with supplemental irrigation. Whatever we don't get from rainfall, we're going to make up with our irrigation system. Sunlight, we can't manipulate that in any way, shape, or form other than removing trees, right? We can't control the cloud cover. We can't control when the sun rises. We're kind of stuck with what we got. So the only other thing left is temperature, okay? And you just have to look at this as we're assuming that we're only looking at temperature, and all of the other potential limiting factors are void and null, okay? So it's the average. Well, let me start with the graph first. So on the left, we have growth potential. 0 means there's no chance that the plant can grow. Temperature is just way too cold or way too hot for photosynthesis to take place. Up the left, we got 100%. That is the maximum that grass can grow based on temperature, okay? So we have our blue line and our red line, our cool season grasses and our warm season grasses. And then at the bottom is temperature. And that's not whatever the temperature is outside. This is the average daily temperature. So how do we get that? We take the high of the day plus the low, and then we divide that by 2, okay? Makes sense? So if it's, if the high for the day is 100 and the low for the day is 50, our average daily temperature is going to be 75, right? 100 plus 50 divided by 2 gives us 75. Okay, so again, assuming no other limiting factors, the max growth for our cool season grasses is 68 degrees Fahrenheit, okay? For C4, our warm season grasses, it's at 87 degrees plus. And you can see the difference here for our warm season grasses up here at 87, where you reach 100% growth potential. That line keeps going. Because here's the thing. If you supply sufficient water, sufficient nutrients, sufficient sunlight to warm season grasses, they will continue to grow at temperatures of 110, 120, 130. We don't know what that actual real world environmental average daily temperature is in which that grass starts to go down, okay? We can induce these things in growth chambers at like 150 and 160 degrees, but we don't see that. That's not reality, right? That's an environmental growth chamber where you can manipulate everything. Okay, so we got 100%, 0%, and this line right at 50 is anything above a 50% growth potential is we are going to consider vigorous turfgrass growth, okay? And a growth potential of 0 means 0, and 100 again is the optimal for the cool season or the warm season grasses. And I like this as an exercise, especially to visualize how the plants are growing in the shoulder seasons, because they're going to grow fast in the summer when we have sufficient heat. Okay, we understand that. So what you can do is you can take this equation and you can take historic temperature data and start plotting a chart, whether it's for Newark, Delaware, for Dover, for Boston, Massachusetts, for Denver, Colorado, for Dublin, Ireland. You can take your historic temperature data, and I'm not going to go through all that right now, but I just want to explain this as an idea. When you plot out, or when you take historical weather data from Dover, Delaware, these are what you get. These are the charts that you get, okay? So remember, anything above 50 is considered vigorous growth. And thinking back to that original chart that I had a big X on, you would think that the warm season grasses are growing out of their shoes. Look, there's only about I don't know, 7 or 8 weeks in the summer where warm season grasses get over, just barely over a 50% growth potential, okay? So just to give you an idea, well, let me back up before I go forward. So let's look at the cool season chart for a second. We don't get to see vigorous growth on those shoulder seasons until sometime in late March. So if we come down here to 50, that puts us sometime in late March to early April, okay? So the grass isn't barely growing by the time we get close to April. And then if we look on the other end of the shoulder season into the fall, basically about late October, the bottom falls out. We start getting cold, and that growth potential starts to decrease. But one thing I wanted to just explain here real quick before I go forward. So here, just in this generalization of the cool season and the warm season grasses, right? So we have a average daily temperature of 68. As you get colder or as you get hotter from that 68-degree average daily temperature, the growth potential is starting to decrease on one side of the curve or the other. Does that make sense? Okay, all right. So for example, we start to get up to 90 degrees. We're really moving down to the right side of the graph. And when we start to get colder, we're moving down the left side. Just to give you a perspective, okay, so this is the chart for Delaware. And I've done this for Newark, Dover, and for Lewis, and these don't change much. These are, if I overlaid them, they'd be almost exactly identical, okay? Just to give you an example or to kind of calibrate you of what this means, this is the chart, the growth potential chart for Miami, Florida, right? Starting in sometime in, I don't know, if we had the months down here, January's on the left, December's on the far right. I don't know, April, May, the warm season grasses in the red line, they really perform really well all the way until, I don't know, what is this, October-ish. Whereas the cool season grasses, they grow really well in January, February, March, and then the bottom falls out because it's so hot in Miami, okay? And then on the flip side of that, just to give you an indication, is that here, this is Boston, Massachusetts. This is what you're typically going to see. There's a much bigger growing season for cool season grasses. Well, it's about equal. You may have a little bit better in the summertime compared to here to Dover. But if we were to draw a line at 50, the warm season grasses never get above 50% growth potential. Okay, so with that said, I looked at the growth potential as a way to try to manipulate the new fertilizer guidelines for the program. And then I also wanted to look at the true science of nitrogen and phosphorus loss, right? So right now, with the old recommendations, they follow the state guidelines of December 7th to February 15th. Was the blackout date. So after February 15th in the spring, you can go out and start applying fertilizer. But in February, if we look back to our growth potential here, I mean, it's almost zero, right? The plants just are not growing. And it doesn't make sense, and in my opinion, I hope I don't offend anyone here, but going out in February and applying nitrogen or especially nitrogen and phosphorus is a little silly. And on the back end too, going out at the end of November after Thanksgiving into December, the plants just aren't going to use it. If the plants can't use these fertilizers that you apply, where do they go? To our water, right? You need plants growing and actively taking up these nutrients in order for them to not be lost. So with that said, 87+% of all nitrogen and phosphorus losses, well, nutrient losses in general, happen between November and March. Okay. Yes, we can still get losses, of course, in the summertime or in April or September. Yes, it's possible, but the likelihood or probability is much lower. Okay. And so, with that said, this is what we came up with, and this looks a little busy, but it's really not. It's quite simple.
Excuse me, on the last page, the last bullet, can you say something about clips and panic?
Yeah, so clipping management can have an impact on the quality of your turf. Turfgrass performs better when you return those clippings because if you have, those clippings actually have nutrients in them. So if you're returning them back to the system, then some point in the future, that system is going to require less nutrients because you continue to return them. As you remove them, that means you're removing them completely from the system. Okay, does that make sense?
Yeah, but yeah, how does that affect the losses of nitrogen and potassium? I guess that's key.
If you have a more robust system, that system is, has a better ability to utilize and capture nutrients.
Oh,
Okay, so here's what we came up with. We'll just kind of walk through this. So right here, we have cool season grasses and warm season grasses. The total amount of nitrogen hasn't changed, but the application blackout dates are quite different. So in the past, June, July, August, you were only allowed to apply a half pound of nitrogen with the old guidelines. Well, that's completely erased. I don't care what you do from March 1st to November 15th. You can apply however you want to apply 3 pounds of nitrogen, you can apply it. You can apply 1 pound every 3 months, every 4 months, however you want to do that. You can apply a 1/4 pound a month or every 2 weeks. However you want to get there from March 1st to November 15th, you can apply nitrogen and phosphorus if the soil test recommends it. You can apply the nitrogen in any method you choose. And so that eliminates that blackout period in the summertime where a lot of these folks with sandy soils were experiencing nitrogen deficiency, right? Because remember we talked about the sandier soils having a poor ability to typically hold on to nitrogen. But one thing that you can do from December 7th after February 15th as part of these new guidelines, you can apply potassium. The guidelines are strictly referring to nitrogen and phosphorus from February 15th to March 1st. So if you want to get out of the gate as a commercial operator and start applying some potassium or some lime or some pre-emergent herbicides with a granular fertilizer, you're more than welcome to do that. Because the reason behind that, because potassium has no impact on water quality. So you can apply all you want, and same with lime, okay? The slow release nitrogen rates and fast release nitrogen rates, those don't change per application. And then the phosphorus, of course, that doesn't change either, no phosphorus, unless you are establishing grass or a soil test tells you that you need to apply it. On the right here, these are just some general best management practices. So this light green area, you can kind of just exclude it. You can look at it if you want. In the future, if you want, these are just general best management practices. But one thing I will say about this exception column is that any of the Delaware livable lawns commercial applicators who are managing athletic fields, you are completely exempt from these applications. Okay, so if you manage athletic fields, you can apply within the state guidelines, and these don't apply to you. Okay, so something that I am 100% confident in. If someone applies well-timed and moderate rates of nitrogen, keeps the nutrients in the low to medium category with their soil test, and or even use MLS and guidelines, and I'll talk about that in just a second. Keeps the pH on the slightly acidic side, okay? That this formula is going to produce the best turfgrass, okay? Let's talk about soil testing for a second. So traditional soil tests for turfgrass systems, they're historically not calibrated to turfgrass. They're calibrated to corn, and soybeans, and commodity crops, right? And so this low, medium, well, when you get a soil test report back, you're going to see something like low, medium, optimum, excessive, or low, medium, high. Depending on where you send it, it's going to be something similar to this, right? This is, I'm just going to use UD as an example. Where low means if your nutrient concentrations fall into the low category, that if you apply a particular nutrient, a response, the likelihood of a response is quite high, okay? But again, these numbers are based on historic crop data. And I don't think anybody in here would agree that if we follow blueberry recommendations for corn, that that's going to work out well for us. It may not, okay? But if we're talking about economic viability, I don't know if I would go that route, but that's what separates turfgrass from other crops, right? We're only worried about aesthetics. We don't care about yield. If we grow grass, based on only yield, we would have to apply somewhere around 10 pounds of nitrogen per 1,000 square feet per year to reach maximum yield. We're not doing that, okay? So we don't need to. And then the medium category, that's going to be a slight chance of response. Statistically speaking, and I'll talk about that in a minute, even in that medium category, there's going to be plenty enough for turfgrass to perform well. The optimum means no response is expected, but I am of the ilk, and I don't want to get too far into the weeds on this, but when you start applying excessive nutrients, right? When I say excessive, anything over than what the plant actually needs for the turfgrass needs to perform well, you're also promoting good environments for weeds, right? And then excessive category, there's plenty, and adding more, especially when it comes to phosphorus, can have some environmental impacts. Okay, so that's typically what we're looking at when we look at standard soil tests. And back in 2015, Doctors Larry Stoll, Wendy DeLertner, and Michael Woods. Larry and Wendy were both, I believe they were pathologists at University of Arizona, and Michael Woods is adjunct faculty at the University of Tennessee. They got together and eventually they started their own companies. This is called Pace Turf with Wendy and Larry, and Micah has the Asian Turfgrass Center. And now they're consultants for the turfgrass industry, and they wanted to try to tackle this problem about nutrient recommendations that weren't specific to turfgrass systems, okay? And so they said, all right, how can we start to tackle this problem? Well, being in the industry as long as they both have, or both of these groups have, they had 17,000 soil samples that they've had collected over the years. And all of these samples came from good performing turf. And that means if any of us in this room look down at this grass, we would say, okay, that looks good, that looks healthy, that's performing well, okay? But think about that for a second, what that means. That means at that moment that you take that soil sample, that whatever the nutrients in the soil are sufficient to grow grass well. Does that make sense? So if I see we could take a blueberry plant or a corn plant. If it looks healthy and it's growing well, we go to take a soil sample, we analyze it. Whatever those nutrients are, that's enough, okay? If it wasn't, it wouldn't be growing well. Does that make sense? Okay? All right. And they wanted to put they needed to get the 17,000 soil samples down to a manageable number. And they also wanted to put some filters on it to get away from salinity issues and aluminum toxicities at the acidic pHs. Because once you start to get a soil pH below 5.5, start getting into the 5.4, 5.3, and down into the 4s, aluminum toxicity becomes a real threat, especially in native soils. You start to get below 8.5, and then you're starting to look at sodium hazards. So they wanted to make sure that they're looking at a pH range that was manageable, okay? All samples came from a 4-inch depth. They used the Mehlich 3 extraction method, which we use here at the University of Delaware. And then they wanted to add another filter to that 17,000 data set, is a cation exchange capacity of 6 centimoles of charge per kilogram. Because 6 centimoles of charge a kilogram, basically that is a really sandy soil, okay? And if you look at turf that's growing well in a really sandy soil with a low CEC, the chances that it's going to grow well in a soil with a higher CEC, the probability is very high, okay? So after they applied these filters, they ended up with 3,700 soil samples. And they took this and they put a distribution over it, right? This is a cumulative distribution function. And I will just kind of walk through these, okay? And they did this for all the macronutrients: phosphorus, potassium, calcium, magnesium, and sulfur. Okay, right here, we just have potassium and phosphorus. So this is the distribution of those 3,700 samples. This blue line are the historic or standard recommendations that we typically get when we submit our samples to the lab, right? So our critical value for historic samples is the average, depending on which lab you use. It might be a little bit higher, it might be a little bit lower. That average was around 110, 105 to 110 parts per million potassium, Male-3, okay? And so what they said was like, all right, well, let's look at the 10% probability mark. And what does that mean? So right here at 10% probability, that means 90% of all those 3,700 samples were producing good performing turf above that number, okay? And 10% of those samples were still producing good performing turf below that number. Does that make sense? Yes, no? Okay, so this is the distribution of all 3,700 samples, okay?
And they were all performing good turf.
They were all performing well. Yes, correct. If we come up here to the 10% probability, okay, 90% of that 3,700 samples have a soil test potassium above 35 parts per million, okay? All of them, 90% of them. And they are performing well. The other 10% are performing well below 35 parts per million. So that number could be 10, 12, 20. So 10% of those 3,700 samples were still performing well, okay? Even below 35 or 35 parts per million potassium, okay? And they did this for all the macronutrients, same thing for phosphorus. This number for potassium ended up being 35 at the 10% probability. That number for phosphorus was 21 parts per million. And so the blue line, if we look over here, we're around 50 parts per million is what the typical average that you might see from a traditional soil test, okay? And here are the current MLSN guidelines. After they put these distribution curves with those pH filters, with the cation exchange filters, with all those filters, these are the numbers that they came up with. So what these numbers represent, these are the bottom numbers. This is the floor of nutrients concentrations in your soil. But also, it has a 10% room for error, okay? Because remember, with these numbers, there's still 10% of that sample set or that data set that were performing well below this number, okay? So pH 5.5 to 8.5, the number for potassium is 37, phosphorus 21, 331 for calcium, and so on and so forth. I think this number right here, this calcium, scared a lot of people because historic numbers were 500, 600, 700. And so that caused room for error. But here's the thing. Well, I'll talk about that again. So here are some complaints with this new way to evaluate soil test data for turfgrass systems. It was too general and broad. A lot of these samples from that sample set, from the original 17,000, came from all over the world, right? It came from California to Canada to Scotland to Vietnam to Japan. They were all over the world. And so a lot of people complained that they weren't regionally specific. Well, here's the thing. I can hire 1 million people tomorrow and we can go out and soil test the world and we won't finish in a lifetime. That's just the reality of the situation. There's no way. We have to start with some amount of data and then try to draw some conclusions from that data, okay? Soils are too variable. Again, there's no way to test every single square inch of land in the world. A lot of times people looked at those guidelines and compared them, the MLSN guidelines, and compared them to the traditional or historic guideline. They're like, oh my God, that's 2.5, almost 3 times less than what we're typically accustomed to. And so they get scared. But the reality of the situation is that turf grasses can perform at nutrient concentrations far lower than what we historically think, okay? And then people have these unfounded fear of nutrient deficiencies. These nutrient deficiencies, it's not this catastrophic event, right? These nutrient deficiencies, they come on slowly. You start to see, for example, with phosphorus, you'll see some purpling of the leaves. Then maybe if you have a soil test or a recent soil test, or you go and take one, you say, okay, it looks like I'm a little low in phosphorus, I can apply some, okay? So there were some fears about the MLSN guidelines. And back to the biggest one was that soils are too variable and it wasn't regionally or state specific. And so now we're getting into some of my research that I just started over the past 2 years, and I'm slowly but surely starting to wrap up. So I said, okay, well, I'm going to take this upon myself as part of my graduate studies to do a soil survey for the state of Delaware. So this complaint is going to be void and null because I'm going to have a data set only from the soils of Delaware. Okay, so what I did, United States Golf Association gave me some funds to drive around the state of Delaware and soil test the world, right? I broke soil probes, I got angry a bunch. Anyways, ended up with 435 soil samples from over the entire state, from Wilmington all the way down to Seaford. Where else did I go? Dagsboro. I went everywhere. They came from golf courses, lawns, athletic fields, parks, cemeteries, roadsides, you name it. Wherever the turf was performing well, I wanted to take a soil sample. And I did a couple. This part isn't really relevant, but I also took some other data. I took some NDVI data, and that's normalized difference in vegetative index. I take this little white gun right there. I shoot it at the turf, and it gives me a number, and it tells me how green, right? And so I'm going to go over some of my preliminary data with you guys here because I don't have the cation exchange capacity or the pH filters on my data. The reason I haven't done that yet is time, but also after looking at the complete data set that I gathered, the 435 samples, we don't really have super acidic soils, at least in the data set that I had. So I had maybe a dozen or a dozen and a half samples in this data set that actually where the pH was below 5.5. And we didn't have any above 8. I think maybe it's like 7.8 or 7.9 was the highest. And so this pH filter, it's not going to change or manipulate the data much, just simply because there wasn't a lot of samples that fell within the super acidic pH or super basic pH. So I did the exact same thing with the distribution and looked at the 10% probability with my data set as they did with the MLSN project. And here's what I came up with. So most of these values from the MLSN guidelines and the Delaware MLSN project are going to put you in that low to maybe even medium category on traditional soil tests. So it's telling you, oh, it's low, it's medium. Well, if the grass is performing well, it's not low. If the grass is healthy and growing well, it has all of the insert nutrient here that it needs, okay? So the University of Delaware, the fertility index value, this is how they report, and anything above 50 is going to put you in that optimum category, okay? And if we break it down into parts per million, that number for Delaware is 50 for phosphorus, 90 for potassium, 500 for calcium, 65 for magnesium, and we don't have good sulfur recommendations. The MLSN guidelines are 2137, 331, and here's my preliminary data, and I'm getting very similar numbers. Okay, so after I apply these filters going forward, there is a potential that these numbers might go even lower. Okay, but they could go higher as well too. But all of my data set is below the MLSN guidelines. So there is no doubt about these numbers. These will work for Delaware because all of my samplers came from Delaware. Okay, we kind of covered new ways to think about nutrient recommendations. And I want to stop here just for a second. Do we have any questions at the moment?
So Sir, are you saying that our soil, it doesn't really need to be fertilized?
I am saying that the likelihood that you need phosphorus, potassium, calcium, magnesium, sulfur is much lower than we thought.
Probably the soil test first.
Right.
That's right. And if you get a soil test and you say, okay, well, I want to follow the MLSN guidelines, that's fine. You can take your soil test from UD or Waypoint or whoever you use. As long as you use a 4-inch sample depth and that lab is using the Malic 3 extraction method, okay? Then you can follow these guidelines if you like. You can do that on your own.
So how often would you have to do a soil test? Do you need to do that like a couple times a year or?
No.
Okay.
No, I recommend doing soil tests every year, okay? And as a homeowner or DIYer, you could probably get away with doing it every 3 years. But for commercial operators, I recommend doing it every year. And that's a way to generate revenue. It increases your engagement with your clientele. And I think it's just the best management practice. And especially if you're going to follow the MLSN guidelines, you probably need your sample frequency probably needs to come down.
Can I just make a point about that? Please don't take your soil sample right after putting your nutrients down.
Oh, yeah.
We just had,
6 to 8 weeks.
we just had a bunch of helpline calls
Yeah.
about being off the charts and everything.
Yeah.
And
So the
Yeah.
rule of thumb is 6 to 8 weeks after a fertilizer application. And whatever you do, I don't care when you take a soil sample, just make sure you have a recently applied fertilizer. And if you always want to take your samples in March, take your samples in March this year, next year, the following year, just in perpetuity, stick with around the same time. Okay, so now, if you have any other questions or you're mulling them over, we can answer those at the end. Now I want to go over a few myths, okay? And these are myths that seem to get ingrained in the industry. I don't know how they got there, but a lot of them are just completely dead wrong. Like anything else in our culture, things get handed down generation to generation or protege to protege, if you will. And with that said, I want to talk about some of these things that just are completely false and not true. So first myth, well, before I get into the myth, this is how I think about growing grass, okay? My first question, is the grass performing well? If the answer is yes, there's enough of that nutrient in the soil. If the answer is no, the next question I'm asking myself, am I sure that that is nutritionally, the reason that it's not performing well is nutritional, all right? Okay, well, if it's not, then we're gonna go down here to our next step. We're gonna soil test and then possibly even a tissue test. And then if that still doesn't cover the reason why it's performing poorly, are we sure it's not a biotic or abiotic stress? Okay, so if the grass is performing well, the chances that you need to add anything but nitrogen are very slim. Okay, so that's how I think about it. And that leads us to the myth of I need to apply fertilizer because the recommendation says so. Well, I just showed you with my data that the traditional soil test recommendations from historic labs, they are much higher than what actually is needed to grow good performing turf. Okay, so with that said, this is from the group at University of Wisconsin-Madison. This is from Dr. Doug Soldat. He's a soil scientist and turfgrass researcher there and a faculty member. And he was doing a phosphorus soil test calibration. This is on a modified sand-based root zone. So it's 80% sand, 20% organic material. I think it's peat is the organic material in there. So it's extremely sandy, right? You put water, boom, it's gone. But nutrients, boom, they're gone at a rapid rate, okay? So looking at this, who would say, so this is for phosphorus, by the way, and who would say that this 4 parts per million, 3 parts per million phosphorus, who thinks that's acceptable? Nobody in here, right? These other ones are acceptable, right? The green ones, okay? So these are showing phosphorus deficiency symptoms. This is just a classic telltale sign of phosphorus deficiency, purpling of the leaves. Okay, so what happens if we take these and we start to add just a little bit of phosphorus, okay? Okay, there's 5 parts per million, we add 1 more part per million. Starting to slightly look a little bit better compared to the 3 and the 4 parts per million phosphorus. What happens when we get to 7? Well, that nutrient deficiency is gone. And there's no difference between the 7, 17, or the 11 parts per million. I want you to think of nutrient deficiencies for turfgrass systems like a light switch. You either have enough or you don't. And once that demand is met, that light switch is on, there's no signs. It's a green, healthy growing plant, okay? And so this is just kind of a graph of what that kind of looks like. So on the bottom, we have the concentration of phosphorus in the soil. On the left, we have visual quality. So we're around, remember, if we go back here, the number in which the light switch flipped on was 7 parts per million, right? So if we look here, anything below 7, okay, there's 0, there's 10, we're about 6 or 7, 8 right in here, okay? So the visual quality or the turfgrass quality is really poor right here. As we start to increase the concentration of phosphorus, the quality improves, right? We're alleviating that nutrient deficiency. And then once we get to around 7, 8, 9, or 10, that deficiency is completely eliminated. One second. And if you apply more beyond that 11 parts per million, you're not going to see any improvement in turfgrass quality. Okay.
Is this pH dependent?
Yes. So, well, no, just between 5.5 and 8.5. So does that make sense? This idea here that it's like a light switch. Once you have enough, adding more does not improve the quality of the turf, right? Okay. Okay, another minute. I am switching to an organic fertilizer program to be more environmentally smart. Okay, I hear this a lot. There is a time and a place for organic fertilizers, yes. But if you are making a commitment to go to 100% year after year organic fertilizer programs, you might want to reconsider. Because here's the thing, nitrogen is nitrogen is nitrogen. Doesn't matter if it comes from chicken manure, bat guano, or urea, or sulfur-coated urea, or polymer-coated urea. It does not matter. It's going to react the exact same way in the soil. And if you apply a pound of nitrogen via chicken manure, it's the same thing as applying a pound of nitrogen via urea or sulfur-coated urea, okay? And then to boot with that, many of our organic fertilizers contain phosphorus. So we don't need to be adding phosphorus unless the soil test tells us to, okay? And then also to add to that, if you apply these organic materials at the wrong time, especially, and I'm specifically referring to, if you apply an organic fertilizer, right? It sits there, it takes time to get broken down by the microbes and mineralized and so on and so forth. It doesn't disappear like a urea would, right? It takes time. And if we get a heavy rain after a big slug of organic fertilizer, the chances of that moving off site are increased, okay? Whereas if you apply urea or sulfur-coated urea, that probability is decreased. Okay, another myth.
John, I got a quick question about that.
Yeah.
Are you gonna add with organic fertilizers, are you gonna add organic material to the soil? And is that beneficial?
With a standard organic fertilizer, like a bagged bat guano or something like that, the amount that you're adding to the soil is insignificant to contribute to the organic matter percentage. If you really want to up your organic matter in the soil, you need a material like compost, right? So that's going to be your ticket to improve organic matter. Okay, second myth, or is this the third? I don't know. Anyways, next myth. I should add fertilizer that contains a micronutrient package just in case. There's a reason why we didn't evaluate the micronutrients in my soil test data or in the MLSN soil test data. It's because micronutrient deficiencies are highly unlikely in turfgrass systems, with the exception of iron, okay? We may incur some iron deficiencies, But the thing is, with micronutrient deficiencies as well as other nutrient deficiencies, they are alleviated rapidly. But here's the thing that I want you to think about. If we look at relative nutrient concentrations in the leaves of turfgrass systems, and we say nitrogen is at a 1, it's 100%, right? It's not 100%, it's about 3.5 to 4%, but we're just looking at relative concentrations here for this chart. If we say nitrogen is at a 1, phosphorus is at about 1/8 of that, potassium is about half, and then calcium is about 1/8, magnesium is about a 1/16, and then our micronutrients are indistinguishable from zero. Okay, they're used so little. So if I was to put that into parts per million, it'll be something like this. That's how much you're going to find in the leaves. The amount that is used by the plant is so small. There's actually, if you get real close, there's a green hash mark up there for the micronutrient. But it's indistinguishable from zero. There are some exceptions, and it can happen, but you don't necessarily need to fret and worry about it, okay? Okay, myth, spring fertilizer is necessary. Well, yes and no, right? That's kind of an ambiguous question or statement, I guess. So we talked about growth potential earlier. If it's not high enough in the spring, so for example, let's say we go out February 15th, that's our first day of the calendar year that we can legally apply nutrients. If we go out and we apply, I don't know, something, whatever nutrient on February 15th, if we think back to that growth potential chart, growth potential is at a 0. That means the plant is not growing. If it's not growing, it doesn't have the ability to take up that nutrient. And so the recommendation is just waiting. Just wait until the growth potential is high enough, and the grass is growing to accept that fertilizer. Another myth. I need to change my soil pH since it is at 6.5 to 7.0. Well, all of my data was 5.5 to 8.5, or all of the MLSN data was from 5.5 to 8.5. And the reality of the situation is that turf grasses grow in a wide variety of soils, and worrying about pH here's the take-home message. Ask yourself, is my pH above 5.5 and below 8.5? If it is, and it's growing well, don't worry about it. Because when you start to apply, if you want dandelions, apply lime. If your grass is growing well and you start to apply lime and you want dandelions, that's your ticket, okay? Because when you start to adjust this pH to these higher, unnecessarily adjusted pH, you're also creating conducive environments for other weeds to proliferate. So you want to make sure that, or you want to try to keep that environment more competitive for turf grasses than you do dandelions or crabgrass, okay?
So on that, we've always been taught with that chart, the optimum. We like our optimum charts, you know, the one that has the graph here, the nutrients down the side that says, it's a bill up and down chart.
Yeah,
So
it gets
that,
bigger.
yeah, it gets bigger. And for each of the nutrients, there is a pH level at which it's optimum.
Right.
That pH level for nitrogen, phosphorus, and potassium is
6.5.
short, right? It's shorter than your 5.5 to 8.5.
Yes.
So
and
our
I'm glad you
soil-
brought that up.
Yeah.
So there was a paper, a bunch of ag scientists, turfgrass scientists, horticulture scientists, soil scientists all around the United States got together, I guess it was 2 or 3 years ago, and they put out this review of pH. And there might have been 20 people on this paper, 20 scientists from around the United States, and they basically said we can throw that away. Because there's so many caveats to where that doesn't hold true. That, I believe that chart is from the 30s. That was originally started in the 30s. And so our understanding of nutrient management for a variety of crops has improved over the last 90 years. And can you follow it and have a general guideline and still grow good crops? Yes, but the idea here is we're trying to do as little as possible to end up with the best grass, right? And we know that we don't have to chase numbers in order to provide a good service. Well, my take home message is just keep it above 5.5 so you don't incur any aluminum toxicity. No. Okay. We're not really going to see 8.5 unless you're right on the coast and you incur a bunch of salt water, right? Or the groundwater is really close to the surface. I know that's quite common here in Sussex, but just think about between 5.5 and keep it above that. I need to apply calcium because my soil test said I was low. There has never been a documented case of a calcium deficiency in a turfgrass system ever. The only way that we can induce true calcium deficiencies is with a hydroponic system. The chances of you incurring a calcium deficiency are slim to none and slim to susceptibility. Okay, so I don't have any faith in the calcium recommendations for turfgrass systems. I would just not even worry about it. I just wouldn't. The chances of you getting if nobody's ever seen a deficiency, the chances that you're going to get one are almost zero, or really close to zero. Adding potassium in the fall will increase winter hardiness and spring greenup. That is absolutely false. Excessive potassium and when I say excessive, we start following some of these traditional guidelines. Excessive potassium in the fall can promote diseases in a variety of our cool season and warm season grasses. Or when you're adding this, it's going to have zero effect at all. So you wasted your time, your money, and you potentially increase the disease probability for particular grass, right? So it does not increase winter hardiness. Potassium does not increase winter hardiness, and it does not improve spring greenup. Those two statements are true. Okay.
Now, when you say disease, is that showing up in the summertime as dollar spot, or is that disease at the time of that?
In the future, it's usually a lot of times you can come up with snow molds, especially.
Yeah, sure.
Snow molds are. There's been a lot of work with snow mold on various cool season grasses, and wherever they're adding more potassium, they have, they start at zero potassium and they keep adding more. Where they start to add these heavier rates of potassium or unnecessary rates of potassium, snow mold just explodes. Wow. And dollar spot is susceptible there too. So if you have enough, applying more is not going to improve your grass. Okay. Okay, next one. I need to apply sulfur as a standalone fertilizer. Here's the thing. So when we apply fertilizers to our turf, it's typically going to be, not typically, but a lot of times it's going to be a sulfur-coated urea, SCU, right? So we have a urea prill coated in molten sulfur, and that is typically going to be enough to supply your turf with sufficient sulfur. And that if you're applying sulfur-coated urea year after year, the chances of you incurring a sulfur deficiency are very slim. But if you say, okay, well, I've seen sulfur deficiency, my soil test said I'm really low, and I'm starting to see these symptoms. You can start, and you haven't been applying sulfur-coated urea, you can start applying sulfur-coated urea, or you can apply ammonium sulfate. So with ammonium sulfate, which is 2100, the analysis, 21% in, it's actually 2100-7. And that 7% sulfur is going to supply your turf with all the sulfur that it needs.
John, are most of the SRNs sulfur coated urea?
They're either going to be sulfur coated, polymer coated, or both. And it might even be methylene urea as well. So your main options are methylene urea, sulfur coated urea, and polymer coated urea, or sulfur coated polymer coated urea. So some of them may have both. Phosphorus is needed anytime I'm seeding or sodding. This is not true. If your soil test says you have enough phosphorus, the seeds will find it. As soon as your seed or your sod as soon as your seeds germinate or your sod starts to get its roots into the soil test that you just took said that there was enough phosphorus. Those turfgrass plants are ingenious at finding it and mining that phosphorus out of the soil, okay? So for example, there's been oodles and oodles of research and studies on this. So if you take a phosphorus or a soil that has enough phosphorus, or the soil test says that this soil has enough phosphorus sitting right next to something that has, I don't want to say this. So you have a soil that has sufficient phosphorus, and then you add phosphorus to the soil right next to it, and you seed or you sod. After 6 weeks, there's no difference, right? And so adding phosphorus, if your soil test says it's good, then that's a wasted effort. Oh, well, I think that's the end. I thought I had one more. I guess that's the end. So the take home here is I see worse problems with turf grasses, turfgrass systems in general, when you over apply as opposed to under apply. So that's kind of the take home message here. I could probably go for another 2 or 3 hours just on my research project and current nutrient recommendations alone. But I guess we're kind of limited on time here. So I think we got like 15 minutes, 10 or 15 minutes for questions. Any questions? Yeah, that's it.
Can you go back to your chart that has the new recommendations?
Sure. This one.
Yeah.
Yeah.
So, under the livable lawns, you're
Right
looking
here?
for, you're looking for, in the November, December, the fall guidelines.
Mhm.
And for pretty much most of them, I thought you said a SRN of 60% or greater?
Let's see.
I wasn't sure.
35%.
35%.
Yeah.
Okay.
And there's individual application maximums that you can achieve depending if you're using slow release nitrogen or fast release nitrogen.
Is this chart on your website?
It is on the Delaware Livable Lawns website. Any other questions? Go ahead.
John, down here, we're having a lot of development take place, right?
Yeah.
And in a lot of these areas where we have HOAs, I mean, our soil media is not really soil media. It's compact and fill. It's got concrete, it's got block, it's got wood in it.
You name it.
And so, number one, great presentation, lots of great information there. But if you're going into an environment like that, would any of this be adjusted or tweaked based on trying to establish a good baseline for your turf there? In particular, where you want access to irrigation.
Yeah.
Some of the nutrients obviously support root development, right?
Right.
And so how does that factor in? Because that's a big challenge for us down here.
So yeah, I
You
know.
can see them in the HOA, you can see them where the townhouses are. I mean, some lawns are drop dead gorgeous, others look like a nuclear bomb.
That's right.
Right? And just comments on that. if you don't
Yeah, so that's a good point. And my response to that is, so the speed and the rate of development down here. So let's just back up a little bit, just so we explain exactly what he's talking about here, right? So when you have a development, you have a new development come in, you have backhoes and tractors coming in there and they dig 10, 15 feet down, they pile that stuff up, build your foundation, build your home, and then they smooth the junk back out, right? And so you're left with growing grass and trees and ornamentals and shrubs and whatever else with poor quality soil. Because as you move down the soil profile, right, the quality of the soil for the hospitability to grow plants in that is really starts to drop off, right? And then that's what you're left with. And so my response to that is, I don't think you need to adjust the nutrient recommendations, but to adjust the soil quality issue, so if you build a home, before the landscapers and the turf guys come in there, to say, hey, can you mix in about a half inch to, anywhere between a half inch to an inch of compost into the top 6 inches of soil? And that is really going to give you a leg up and improve the soil quality and the texture. So down here, we're dealing with sandy soil, right? So compost does a couple things. So for sandy soils, you're gonna increase your water holding capacity and the porosity. And plus that compost has slow release nutrients in that. So you're kind of killing 3 or 4 birds with one stone. But let's say we're doing this up in, I don't know, Pennsylvania somewhere where we have a high clay content. Put compost into that soil and it's also going to do the exact same thing. I know it's kind of counterintuitive, but it also improves the water holding capacity, the drainage of that clay soil, and as far as the quality as well too. So does that kind of answer your question a little bit?
And on that point, I heard a giggle behind me or a laugh behind me because very few of us who have bought new homes down here in Delaware, I moved down in 2016, had the option of having them put a layer of topsoil down before the sod was laid and everything.
Yeah.
So I live in Plantation Lakes and I have a basement.
Yeah.
And I have an 8-foot basement ceiling. So they dug all that substrate up and they basically laid it around the house, compacted it down, and then laid my sod on it. So when I did my walkthrough, I went through and said, will you replace the sod in the spring? And they said, no, it's just dormant. And I went over and I went like this. I said, this is not dormant. This is dead. And I could pick up 4-foot pieces.
And you know,
And no, they
I've
wouldn't.
heard that story
Yeah,
so much, or a story similar to that
yeah.
many times. And, you know, my only response to that is if you are building a home, or if you know someone building a home, or if you're in charge of an HOA, I would highly recommend that you make I don't know if you can make it a bylaw in your HOA constitution, but if you could say prior to installing any kind of plants, turf, ornamentals, what have you, that the company needs to incorporate some compost, just because,
Yeah.
maybe the builder, maybe they did leave you with a little bit, but
Right.
maybe they didn't also. So compost works both ways on that. So,
But you know, the thing there is you don't have access to your HOA bylaws until it's turned over to you. So right now, the builder is the one who has our HOA bylaws. But in 8 years, I've taken my organic matter, my first soil test was 0.06%.
that sounds about.
So I'm up to 2.1. But I have added in the spring and fall, I've core aerated like every 3rd year.
Yeah.
And I've added a 1/4 inch of compost. And this, I have to say, this is the first year my grass looks really nice.
Yeah, and
And
that's a good take home message. So if you already have an established turfgrass system and it just struggles year after year after year, and you're like, man, I've got to put a bunch of water on it. I've got to add a bunch of nitrogen, blah, blah, blah. You can aerify and then do a light top dressing for a couple years in a row. That's going to be sufficient to produce soil quality.
You said something earlier about if you put fertilizer on at the wrong time, when the grass can't use it,
Yes.
but does it go away? What happens to it? I mean, I know there's a certain amount of water runoff, but
Well, if it's organic, right, and you apply it, let's say you apply an organic fertilizer early in the season or just before heavy rain event, right, that material can move. I don't know where it's gone, but it's not going into the place that you put it, right? Like you're applying it to your grass or to your plants or whatever the case may be, and you're anticipating that with what you just applied is going to be taken up by your plants. But if it moves off site,
But if it doesn't move off site, I understand what you're saying about runoff. Yeah, there's some runoff, but not always.
No, not if it's.
So what happens to it? Does it stay there?
Yeah,
Can
if it doesn't get
It
run
could
off.
be used later.
That's correct.
That's what I was trying to say is
Yeah,
it doesn't just evaporate or something.
no, that's correct, right. The only way that it can move is going to be runoff.
Right, okay.
Yeah.
Thank you.
What kind of compost do you recommend for a established farm?
Well, we have a few good compost spots around here. So up in the north, we have southern PA, they are kind of the mushroom capital of the world. They've got some really good mushroom compost. We are the chicken capital of the world. We've got a bunch of compost down here. There's a couple of producers in this area. I'm not going to start recommending names because I can't do that. But if you just search compost producers near me or compost producers in Delaware, you can come up with a couple solutions. Any other questions? Go ahead.
If there's no other questions, we get a lot of calls on the helpline and we're working with a lot of HOAs that live near water, marshes, bays, creeks. I mean, down here in Sussex County, we've just got water everywhere.
Yeah.
And we've got concerns about landscapers applying product where it's a fertilizer and pre or post emergence. And some of them, can you just talk a little bit about the pre and post emergence and their effect on waterways? Or
So here's the deal with
That's
this,
fine, I
with those materials. That's fine. I can talk about it. Before these products get greenlit to be used by the industry, homeowners, whatever, they are the process to get them okayed by the EPA is vigorous. Okay, they have to test the leachability of the products and so on and so forth. There's a lot of research that goes in to getting something past the EPA and usable for homeowners and industry clientele or industry folks. And if you apply, and all of these restrictions and stipulations and hazards are going to be on that label. If you follow that label, then theoretically speaking, you should be in pretty good shape. But you know, let's be honest here. Sometimes those things don't happen. But that's above my pay grade.
So I don't really know too much about turf, which is why I'm here. So I don't know if this is a dumb question, but what is a pre-emergent? And is that used in conjunction with a fertilizer? Are they two separate things?
They can be two separate things, but they can also be together. They can be applied as a liquid, or they can be applied as a granular. So you can take a fertilizer granular or a krill and coat it with sulfur to create a slow release product, or you can also coat it with a herbicide or a fungicide, insecticide. You can coat our granular fertilizers and just about anything you can think of. But no, they are. Let me just go to the board and I'll just show you real quick how pre-emergent herbicides work. Okay, so here's our soil, right? Here's our seeds that are in the ground, and then you apply either a liquid or a granular, and it creates this thin little barrier right here, right? Just below the soil surface, okay? And this is a herbicide, right? This is whatever pre-emergent herbicide that you apply, okay? So what happens is seeds germinate, right? The column comes up like this. It wants to come out of the soil, right? But as soon as it hits that barrier, it takes up the herbicide and dies. So there is a little misnomer, might as well debunk another myth here while we're at it, but a lot of times people think that pre-emergent herbicides stop the seed from germinating. No, the seed germinates. It's just that the first plant part to come out of the seed comes in contact with a thin chemical barrier or herbicide barrier right below the soil surface. Once it takes up that herbicide, it's dead. Does that make sense?
is that pre-emergent mobile in the soil?
Well, when you say mobile, you mean like, can it move off site real easily?
Yeah.
No, it does get broken down by biological activity.
Right.
Water and biological activity would drive the longevity of pre-emergent sites.
So in other words, piggybacking on what you just said, if you have a pre-emergent, you were gonna overseed or something, is there a wait time that
There is.
would go through there?
Yeah, it's going to be on the labels. It's different for all the pre-emergents. There's a slew of pre-emergents that you can apply, and the wait time to actually seed something desirable, some grass, for example, it's gonna be different for each product. It's hard for me to say.
I'm
Go
glad you
ahead.
started talking about.
Go ahead, you go first.
I'm glad you started talking about emergence, because pre-emergence, because it's one of my major questions. When you use a pre-emergent, and you examine the product, what is it, and what does labels tell you that tells you the pre-emergent is safe for runoff, safe for wetland runoff? Well, I've heard people say, well, yeah, I'll use a pre-emergent, but it's okayed by whatever to get into the runoff.
Well, we just have to trust what the EPA is telling us, right? I mean, whether you want to trust them or not, I'm pretty confident with it. But they consider those things when they,
Right.
okay, or particular herbicide products or pesticide products in general. And so there are ways that you should apply this, or proper ways and improper ways, improper barriers, or there's going to be barrier distances between water bodies. Like I'm just going to throw out a number here. Maybe this particular herbicide label says you should apply, within 25 feet of any kind of water body. Another one may be 5 feet. It just depends on the particular product. And I can't honestly sit here.
What do you look for on the label though?
You mean distance? Like as far as.
Is that what you look for, the distance?
Yeah, it'll tell you. It has to tell you.
Pre-emergent would be safe as long as it's far enough away from a body of water, is it what you're saying?
Yes, as long as you follow the.
So when you put with pre-emergent in the turf, in a dry pond.
Now, I wouldn't recommend that.
So.
That's, I
I
know,
see what you're trying to get at. right here.
It's a saltwater facility.
What it is,
Yes.
is that I don't think anything is allowed to go through a home. Things are approved to use in aquatic areas such as a dry pond, such as things like that. And what you're looking for on the label there is for it to say approved for use in aquatic areas.
okay, that's what I was looking
Yeah.
at.
And there's
So
different
just
licensing
the label,
companies.
I hate reading labels. I absolutely loathe it. There's so much information in there. Some of it is useless, but some of it is very important. But please open it up, read the label from front to back. And if you read the label, I promise, everything that has been researched and the best management practices for that particular product is going to be in that label. I promise you. It has to be by law, it has to be.
Can I ask you a specific question then? So looking.
I think he was next.
Oh, I'm sorry.
The test levels that go along with these new guidelines, are they also on the, Livable Lawns website, Livable?
This is on the Livable Lawns website.
Okay, but earlier you were, someplace you had a chart where you said, the new levels that were.
Tell me when to stop. Oh, I went too far.
Yeah,
Make it slower,
you had that.
This, yeah. So right now, the Delaware Livable Lawns program follows University of Delaware, the current guidelines.
The FIV.
That's right, right. And if you want to convert FIV to parts per million, there's, so your soil test right here, where is that? Yes. So if your soil test is 50, that's going to put you in that optimum category. And look, I'm not saying that these are wrong. You can grow really good grass with these traditional numbers, right? But I'm just saying that we can apply less.
Yeah, so where do I find the MLSM numbers outside of your chart, or this presentation?
Yeah, it's better if I send you an email. How about that?
I'll just.
I'm gonna get your USB and put it on when I get back.
Okay,
Online.
all right. I'll give you a card and you can either call me, reach out, and I'll send you all the information you need. Okay. That you're interested. Okay. Yeah, go ahead.
The chart that you showed, the squares of the turf,
Yep.
hold that right there. One you just had.
That's
You
right.
had from 7 to 17 and anything over that, it didn't change on the E.
Yeah,
That there was showing me 50. We're looking at one of our soil tests, and we're like, with 42, and you're showing it on that blue graph. What's the,
hang on, let me, tell me when to stop
the blue graph you just had, the blue chart?
with the nutrient levels.
Yeah. What's, right there, what's the conversion, that 50 to P part from
Is that from UD or?
No, it's from AgriLab.
And what is the number?
I got 42.
42.
Yeah, so that's is it parts per million?
Yeah.
Yeah, so you're double of what the MLSN guideline is, and you're double, almost more than double.
Now show, yeah.
So left,
It's showing 11?
left.
Yeah, so it's calibrated to these old,
Okay.
old,
Ag.
yeah, and so like,
Okay.
it's low for corn.
Yeah.
That would be low for corn, but it's not low for turf.
Okay. I didn't know if
If
there was
you're- if you're above-
conversion or a breakdown.
Yeah, so something, just to explain the MLSN and the UD MLSN numbers, is that if you get a soil test back and it says 18, you're like, oh crap, I'm below that number. Well, guess what? 10% of my data set was still producing turf, good performing turf below this 19 parts per million in my data set. And in this data set, the national and international data set, it's 21. So you don't need to run out, be like, oh my God, I need to apply. Well, again, that's just something to think about. Say, okay, well, maybe I don't need to apply this year, or maybe I can wait till later in the year if you start to get real close to that. But here's the thing. This is almost the MLSN and the Delaware MLSN numbers, these are almost 2 to 2.5 times less than standard recommendations. So even if you just applied a little bit, when you get close to that, it's going to be sufficient.
Any
Any other questions?